The intent of this is to help educate and inform potential clients and others who are watching the podcast of how we see the market, how we see ourselves in the market, and how we see the industry as a whole. So the hope is that there's learning lessons from this that you can apply as a potential client of ours or as a user of Additive to be able to make informed decisions about how you leverage additive. Our belief is that additive manufacturing adds real value. It has the opportunity to make real difference. And whether you're working with DI Labs, you're doing it yourself, or you're working with others, it has the ability to make a real impact. So we're going to share about that impact from our unique perspective. What's the difference between buying a printer, plugging it in, printing parts, and then leveraging a printer, implementing a digital workflow, ensuring traceability, consistency, and repeatability? Those are two different things. Buy the printer, you use it, and then you implement a workflow that supports consistent production. And of course, we're talking about this on an industrial scale, so we're not talking about FDM printers run in your basement. We're talking about industrial scale machines running in a facility.
Well, regardless of the technology that we're talking about additive, we're talking about industrial manufacturing. And all industrial manufacturing has a ton of variables to manage. And if you don't manage those variables right, that's the difference between setting up a printer and producing parts and then being methodical and conscious and intentional about controlling those variables so that the output is as consistent as possible. So that's one approach to look at this, setting up a printer and making parts compared to having a digital and physical workflow that maximizes the control of those variables so output is consistent.
You know, it's interesting because we asked this question, and that's the conversation. Printer manufacturers are promoting the equipment in terms of plug it in and go, plug and play. They're not saying that exactly, but that's the connotation because the interest is in selling machines. I don't know that I've ever experienced that for injection molding machines. I don't know that I've ever, of course they say that you can plug them in and go, but nobody is saying, hey, should I just go buy an injection molder and plug it in and start making parts next week? And it's interesting because we don't talk about other manufacturing or plastic processing processes in that way, but we talk about 3D printing and additive manufacturing. And what you just said is really important. Those two are all manufacturing tools. Additive manufacturing and injection molding are manufacturing tools. And we shouldn't be thinking about one as a simple plug and play if we're not considering them all to be, because we have process controls for all of them. We have facility controls, infrastructure, and to me, to us, that's the big difference, is that we're looking at additive manufacturing as a manufacturing process that requires a great deal of process development, infrastructure, the right team members, the right people to be able to operate the equipment successfully and consistently.
It's interesting to think about that dynamic with plug and play with injection molding and plug and play with additive. I think there's particular use cases for a design segment of a business to have some plug and play equipment so they can do rapid prototyping, and the variability is high because you likely have engineers or a small team managing those parameters. But where that doesn't work well is on a production grade industrial piece of equipment, injection molding, whether it's an injection molder where you're managing tools and the process, or you're managing an industrial additive manufacturing 3D printer. Those in that environment tend not to mix well because you don't have all the infrastructure there to support the variables. You know, it turns into a massive R&D. And in that case, R&D is okay, but it's not the sort of repeatability that we're looking for when we're manufacturing and controlling our parameters.
You know, that's absolutely right. And it's funny to think about what you just said and this conversation and think back to our first industrial machine that we purchased. And we've got backgrounds in manufacturing and injection molding and extrusion and thermoforming. So we've got these backgrounds, but we got into additive manufacturing on an industrial scale in 2017. and we brought the machine in, and the expectation was that it was plug and play, that we'd be able to plug that thing in, get the wiring going, and start printing parts. And so it was probably, I can't remember exactly how long it took us to start to understand the significance of bringing on additive manufacturing. But it got to a point where we started to shift our mentality from plugging in more machines to get more parts, and looking at it more from a holistic standpoint as a manufacturing endeavor. And that shift, it just didn't start that way because it isn't being promoted that way. So we've evolved ourselves as we've grown.
The learning curve is steep on the front end. If you were to, for the very first time, bring in a new technology for manufacturing, that learning curve it's intense. Whether it's additive or injection molding, if you've never injection molded before, the variables are unknown, and you have to become familiar with those variables so that you can control them. The same goes for additive.
One of the great things that happened through the pandemic is that we saw filament printers everywhere in the news, and they were serving important applications, EHS applications, masks, swabs, and things like that, and that could all be done in someone's basement and had a real impact. And it was really good for the additive manufacturing industry because now the public starts to see real applications of applying this technology to solve problems. That's really good. The disservice that I think it did is that everybody was running these machines in their basement, and it was plug and play. And I believe that some of that filament, that feeling that you can just plug a filament printer in and start printing parts, that has been inherited by many of the other printing technologies, in that you could do the same thing with these other technologies. And that's probably the disservice that happened in that whole experience. In running powder-based systems or photopolymer-based systems is dramatically different than that of filament, especially if you're running them at scale and you're trying to produce the same parts every time.
Yeah, it makes me think of it's like the data sheet that the vendors hand over to you. Here's your cost of goods, and this is what it'll cost for you to run this machine. It's always short so many details of if you're adding this one machine on to a bank of 100, those might be close. But if you've got 10 machines or 5 machines, it's so far off base what the real cost of operating. That's doing another disservice because as potential users of additive are going out there and looking at this new equipment, they're seeing what these costs are. And then they're saying, oh, I can do this. I can bring this on in-house. And it turns out to be way more complicated than you could ever imagine.
So if I'm a customer leveraging additive manufacturing, why do I care? Well, that's the question. For us, we've been the customer. So we've in the past we've outsourced parts to other service providers, either for our own internal needs or for our customers. And oftentimes it's for technology that we don't operate ourselves. And we've learned the hard lesson. We've learned hard lessons. Almost every one of those times, there was some aspect of the deliverable that did not meet expectations, whether it was time delays, quality delays, providing maybe the wrong material, and it matters because time. Time is our most precious resource, and that's what we were talking about here recently. And all those times where we've been burned, it cost us significantly from a delay standpoint when you're waiting for a part for a week and then you have to start from ground zero.
And that's our approach. The thing that is most critical to us is it's time. Setting up our processes, having processes in place for our manufacturing, controlling these variables allow us more of that time variable so that our chances of having defects and parts that don't meet the requirements are much lower than if we were to not control those variables. So the piece that we're managing is really that time. So we're not reproducing, we're getting the order out to meet expectations the first time.
And if we are reproducing, which happens, scrap happens. We're doing it within that time cycle so that we're able to meet the demands rather than pushing production back, which puts things in a bind.
That's right.